notifications here. If you change anything, any manual changes will be lost when you save some changes in the input asset. So if you want, go ahead and read through in order to see how all of this works. But in order to use it, it's actually super simple. You don't need to worry about this script. First thing we need is to construct our script class that was auto-generated. So let's do it over here in our game input. Let's make a private void awake, and on awake, let's construct it. So let's do a new player input actions. So we construct an object of this type. So we have this, although just like this, it won't be active. So we need to manually activate whatever action map we want. So let's go inside and let's go inside the player. So this is the action map that we created, and let's call enable on it. Okay, so just like this, it's really already working. All we need to do is modify our code over here on the get movement vector. So for that, we're going to need to access this. So let's actually make this a member variable. So private, let's store it up here instead of making a local variable in here. Okay. So we have this one, and then down here on the input vector, let's go inside the player input actions, inside the player action map, and then we called it move. So we've got this one. And then we defined it as a vector2. So over here we can call read value. And this one takes in the type of the value. Now we defined it as a vector2, so let's read it as a vector2. And just like this. This returns a vector2, which is really going to be our input vector. So let's put it exactly like this. And we can now get rid of the rest of it. Alright, so that's it, and just like this, we should already have everything working exactly the same as previously. So let's just do a debug.log just to make sure. So let's test. So here we are, and the output is 0, 0. Now I press W. There you go, +1, -1, left, right, and all of the ones in between. Alright, awesome. So we have the new input system, all of it working flawlessly. Also, by the way, over here we can normalize the input just like we were doing previously, so we do it over here through code. Or alternatively, we can also go into the player input actions, and over here there's something called a processor. So you can go into this action, add a processor, and make it normalized. So these processors here can be quite useful. I covered them all in detail in the other dedicated video, but over here, let's stick with making it through code that works just as well. Okay, so that's our refactoring done. With that simple change, we are now using the new input system. So you can see how by refactoring our code to make sure to use the game input class, when we changed from the input manager onto the new input system, when we made that change, we did not have to touch the player class at all. The player class just has the game input to get the movement vector and does not care what system it uses to get that. So here we have a very practical, very excellent example of the power of writing good clean code. Because we separated things correctly, we managed to change something completely and not have to make any changes on any other class. So now that we're using the new input system, let's just quickly see one of the main benefits of this system, which is easily supporting gamepads and more keys. For example, a lot of people like using WASD, but some people also like to use the arrow keys. With this system, that is super easy to add. So let's go into the move, let's add another one. Let's add another one, up, down, left, right composite. Let's call it arrow keys. Then let's just put them. So let's listen on the up arrow. Then over here we've got the down arrow. Then we have the left arrow. And finally we have the right arrow. Alright, so we've got all the arrows. And now we don't even need to touch any code at all. Let's just make sure to save the asset, which again, in turn, that is going to auto-generate the C# class and going to compile. Okay, so we don't need to touch any code at all. Let's just hit on play. And now if I move, we're using the WASD keys, yep, still works. And if I go into the arrow keys, yep, also still works. Alright, great. Now for another one, let's make it for a gamepad. So I just connected an Xbox controller, and we can see over here on the log, yep, the game did identify it. So this is the new input system in action. Let's once again open up the input actions. And over here on the move, let's add another one. And this time, let's just make it a regular binding. And now over here on the path, once again, if we want, we can go down here and specifically find some joysticks. So you can find any of them, or once again, let's just use the listen. Now I'm just going to move the thumbstick on the controller. Yep, there it is. And now if you wanted, you could go specific and make it just work with Xbox controllers, or you can just use the generic left stick. This will make it work with an Xbox controller or a PlayStation or really anything. So let's go with this one. And that's it, nothing else we need to do. Let's just save the asset and that's it. We don't need to touch any of our code to make our game playable with a controller. So let's go ahead and test. So here we are, and first of all, if I move the keys, yep, still works. Move the arrow keys, yep, both of them works. And now if I use my gamepad, and yep, there you go, everything works perfectly. Alright, awesome! So as you can see, this is one of the main benefits of the new input system. It makes handling different inputs really super easily. As you saw, we didn't have to touch our code at all. We just add new bindings, and just like that, our game is playable with all kinds of inputs. So here you can really see just how powerful new input system is. Okay, so with this, our basic character movement is working great. We can walk around, everything looks great. Now in the next lecture, let's apply some collisions to our player. Hey again, here's another quick intermission. I hope you've already learned a ton from the course. Have you seen the benefits of writing good clean code? Has the course already helped you understand some more advanced concepts? I really hope the answer is yes to both of those. Remember to follow the website page as you follow along. I will be adding frequently asked questions to every lecture. If you ever get stuck, you can just download the project files for a lecture and compare with your own. And definitely check out the related videos when I reference them. This course is focused on making this game, but you should definitely learn more about some of these concepts in more detail, and you can learn that in the videos that I mentioned. By the way, if you're watching this right now, this is the secret callout, so go ahead, post a timestamp in the comments with a nice monkey emoji. I want to see how many people make it this far. Okay, so that's it for now. Let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to apply some collisions to our player movement. Okay, so here we have our game so far. We have our player walking around and everything looks pretty good. However, now let's create over here in the hierarchy, let's right click, create a brand new cube. So there you go, let's place it over here and push it down. Okay, there's the cube. Make it just a little bit bigger. So there's the cube, and by default it has a box collider component, so it has physics. And the player, if I move, and nope, there's our issue. The player is going right through the object. Now the player is not meant to be a ghost, so let's fix this. Over here in our player script, we are carrying the input vector, calculating the move direction, and then just moving the transform. So right now we're moving it no matter what. Now before we do that, let's first do a test to see if any object is in the way. And how we're going to do that is by firing a raycast. This one is a physics operation that basically fires a laser from a certain point towards a certain direction and then tells you if it hits something. How we do that is let's go inside the physics class and let's call the raycast function. This one, as you can see, has many versions of this function with all kinds of parameters. Let's use this one, option number 7, which takes a vector 3 for the origin, a direction, and a max distance. So first for the origin, that is from where we want to fire our raycast, let's put the player object in, so that's transform.position. Then for the direction, this is going to be our move direction, so let's use our move there. And finally for the distance, let's use some kind of player size, player width, something like that. So let's define up here a float for the player size and put it at 0.7 units. Let's try out with a size just like this. Okay, so basically this returns a boolean. It's going to return true if it hits something and false if nothing is in the way. So let's just do a bool, call it can move, and basically we can move if this raycast doesn't hit anything. So we can move if this one is false. So if the raycast is false, then can move is going to be true. That's very simple. So if we can move, then we move the transform position, otherwise we don't. Okay, that's it, super simple. Let's test. So here we are, I can move around, and if I go towards the cube, and nope, no longer works. So I can no longer go inside that cube. Okay, great. Now in your case, if it's not working, first of all, make sure that the cube, make sure it is touching the floor. We use the transform position as the origin, which is right on the floor. So if the box is raised up, then you won't be able to go through, so make sure the cube is touching the floor. Also make sure the cube has a box collider component. It can be any type of collider, but if you made a cube, then it should have a box collider by default, and it should have the same shape as the visual. And also remember that the 2D and the 3D physics systems, those are completely separate. They are completely different worlds. So make sure you're using 3D components and not the 2D ones. So for example, if I add box collider 2D, if I add this one, then it will not work. So make sure you're using the 3D and not the 2D components. Same thing over here on the script, make sure you're using physics and not physics 2D. Also finally, if you're still having issues, make sure you check the player position. Again, the player should be on a Y of 0. The only thing that might have an offset is the player visual, although if you're using the same asset as me, then this one should also be on a Y of 0. So all of these on Y of 0. And then you can also check the floor. By default, this one has a mesh collider, but if it is exactly on Y of 0 with no rotation, then it shouldn't cause any issues. Alternatively, you can also just disable or remove the mesh collider from the floor, since we're not going to need that. So with all of that, yep, everything works. I can move the player, but I cannot go through solid objects. All right, awesome. So it is working, but for this particular use case, a raycast isn't necessarily the best method we should use. Basically, a raycast is, like I said, kind of like a super thin laser, but as you can see, the player visually has an actual body shape. So the visual and the logic are using completely different shapes. If I go ahead and push towards the box, you can see it works just fine. However, if the player is a bit more off to the side, and the center of the player right in front of it is not the box, and I move, and yep, there you go, now I am going through the box. The reason is because the raycast is being fired from the center of the player, and like I said, it's kind of like an infinitely thin laser, so it has no shape. So as long as the center of the player is not hitting the box, then it can go through it. Whereas what we really want is for the visual and logic to have pretty much the same shape. So let's not use a raycast. Over here on the code, instead of a raycast, we can use a physics query with an actual shape. There are all kinds of casts you can use. And as you can see, all of them with different shapes. So you've got a box cast if you want to have a box, a capsule if you want a capsule, or a sphere cast. All of these work pretty much the exact same way, except instead of a raycast which fires an infinitely thin laser, these are going to have an actual shape. And for player controllers, for the most part, you really want to be using a capsule cast. That's usually the generally accepted player shape. Although alternatively a box cast also can work very well. In our case, let's just go with a simple capsule cast. This one, to define a capsule, has a 0.1 and a 0.2. By the way, if you have no idea what is a capsule, then we can go over here in the hierarchy and let's right click, create a 3D object, let's make it a capsule, and there you go, this is a capsule. It's kind of like a stretched sphere. So it has rounded top, rounded bottom, and then over here in the middle, it's just a cylinder. And over here for the raycast, takes a 0.1 and a 0.2, so that is going to be the bottom of the capsule and the top of the capsule. Basically, with those 2 points, we can define the height of the actual capsule. Okay, so let's just get rid of this capsule. Let's just delete it. And over in the code, let's put those. Now for 0.1, it is indeed going to be the transform.position, since that is the point at the bottom. And for the second point, for this one, it's essentially going to be the player head. So we can take the transform.position, so this is the bottom, and we can essentially just lift it up. So let's add a vector3.up and multiply by some kind of player height. So let's define up here a float for the player height. And I tested it in the editor and the player is about 2 units tall. So over here, let's go ahead and move it up by that much. Okay, so next we want the radius. So this is pretty much the player size that we defined previously. So let's use the same thing. But as always, let's make sure to write good clean code. Since now we are referring to a radius, let's actually rename this to be a bit more clear. And by the way, here's a quick Visual Studio tip. You can right click on a symbol, and then you can click on the rename option. Alternatively, use the shortcut Control R, Control R. If you do that, then now you can change the name. So for example, player radius, and note how it changes every single instance of that variable. So this renaming feature is extremely useful. Always make sure to rename something if you find the name that works best. Okay, so let's rename this to player radius. Then we have direction, so that is as usual going to be our move direction. And then finally we have the move distance. For that we can use the actual move distance. So that is going to be the movement speed multiplied by time.delta-time. So I just find here a float for the move distance. And we just do that, just move speed, time.delta-time. We have the move distance, and we use it both in here as well as down here. Okay, so here we have our capsule cast. The rest of the logic is exactly the same, so if this one is false, that means it didn't hit anything. So if it didn't hit anything, then we can move, and then we move the transform. Okay, let's test. And over here, now if I go towards the box, and yep, still works exactly the same as previously, that's great. And now if I go towards the edge, and make sure that the center is not hitting the box, and now I try to move forward, and nope, now we no longer go inside the cube. So even on the edges, everything still works perfectly. Alright, awesome. So it works, it looks good, but it also is a little bit janky. For example, let's stretch this cube out a little bit, so let's put it just on one direction, so stretch it like this, let's see. Now if I move towards it, then nope, I cannot go through it, so that is correct. And if I move left and right, yep, that's also correct, that works. However, if I now press W and D at the same time in order to move diagonally, and nope, right now it does not move. The reason is because the diagonal vector, that one is indeed hitting the collider. But usually in games, when you move diagonally and you cannot move in one direction, then it tries to essentially hug the wall and move around it. So if I press W and D, it should essentially be moving straight to the right. So let's solve that. So here in our code, we're making our capsule cast. Okay, that's great. Then we need to test if we cannot move. So let's do if we cannot move. So if can move is false. If so, then that means we cannot move towards this direction. And if we can't, then essentially we basically want to split the movement direction and just move on the X or just on the Z. So first, let's attempt just the X movement. So attempt only X movement. Let's create a new vector3. Let's call it move dir X, and we make a new vector3. let's take in the move dir.x, then 0 on all the others. So we only want to test moving in the x direction. And then let's do literally the same thing. So let's get our can move, try to move under this direction. So let's go instead of move dir on the x. So we do that capsule cast. And if we can move, then that means we can move only on the x-axis. So can move only on the x. And if so, let's set the move dir equals the move dir x. So if we can move, then down here when we use the move dir, we're going to move only on the x. And if we cannot move, then that means we cannot move only on the x. And if so, then let's attempt only z movement. So over here, again, let's do the exact same thing. So let's copy this. Let's just change this one. So instead of move dir x, we've got move dir on the z. So over here, we use 0 on the x, 0 on the y, and access the move dir and get the z. Then let's use this movement direction over there. And finally, the same thing. So if we can move, then that means we can move only on the z. And let's set the move dir equals the move dir z. And if not, then we cannot move in any direction. Okay, so that's it. Now this might seem a bit confusing, but it becomes a lot more clear when you see it in action. Again, remember the scenario we're trying to solve, which is when moving diagonally. So for example, when we're moving forwards and to the right. If we do that, then let's say this one is going to hit something, so we cannot move. So if we are trying to move both forwards and to the right, then we're going to only attempt the x movement, so we're only going to try moving to the right. And then we're going to see, yep, going to the right, that does work, so we can move, and we're going to move just to the right. Alright, so let's test and see if all of this is working. Alright, so here we are, and if I move straight to the wall, and nope, there's a limit, so I cannot move anymore. Okay, great. Now if I move just left and just right, then it does work. Now if I press W and then D, and yep, there you go, now it does hug the wall and continues to move. Same thing if I go on the left, so over here if I press D, no I cannot go through it. Now if I press D and S at the same time, and there you go, it hugs the wall and moves around it. So now our controller is much more easy, much more understandable. Okay, so this is great. Now this is one of those tiny things that makes your character controller feel much more responsive, so that's great. However, we also do see one more issue. Right now you can see that I'm right next to the wall, and if I press A and D, then look at that, I'm moving with this speed. However, now if I press W and D, look at that, now I'm moving diagonally and it's actually moving slower. Basically, this is the same issue that we saw previously where we had to normalize the input so we didn't go faster in diagonals. Basically, now we have the opposite problem. Since we are normalizing the vector, we are cutting down on the left-right vector. And with that, basically, if we are moving diagonally, then we are essentially going slower, whereas if I stop moving diagonal and just move left-right, it moves at a different speed. Now the solution for this is really super simple. Over here in our code, when we are constructing the move dir x and move dir z, when we do this, very simple, let's just normalize it. So if this one is less than 1, then it will be going into 1. So let's normalize that one and that one. Okay, that's it, let's test. And now if I'm here, move forward and hug the wall left-right, yep, it does work. And if I stop moving diagonally and just go left-right, yep, all still works with the exact same speed. All right, awesome. Okay, so that's really it. As you can see, it's super simple to add collision detection to your movement scripts. You just do a physics query to test if our character should move and just move it. By the way, if you want to learn more about collisions and physics queries, there's a bunch of interesting videos that you can watch. For example, one is on various methods of finding a target. Then another one is on various methods of handling projectiles. And finally, another one is a very quick checklist on why collisions are not working. Basically, there's lots of really interesting things you can do with physics, so make sure you understand these functions. Okay, so now that we have all of this working, let's first just clean up our scene. So over here, our default cube, we don't want this, so let's just get rid of this. And with this, we are ready to build our first kitchen counter, and let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to begin building one of our main game mechanics. We're going to make a kitchen counter and handle the logic for the player to be able to interact with that counter. Okay, so let's begin by making our kitchen counter. And just like we did when we made the player, let's first make an empty game object and place the visual inside of it. So let's right click on the hierarchy, create an empty game object, call this the clear counter. So it's going to be clear on top so we can place and pick up objects. Let's make sure to reset our transform, so let's put it on 0, 0, 0. Let's move it just a little bit, just so it's not exactly on top of the player. Okay. Now inside, let's add the visual, so let's go inside the assets folder. And then over here, we've got the prefabs visuals, and inside we've got the counters visuals. And over here, let's find the clear counter visual. So let's go ahead and drag it inside the game object. Again, make sure the child visual is on 0, 0, 0, the local position. Okay, great. Now, just like we did in the last lecture where we added collision detection, that should already be working by default, but in order for it to work, it needs a physics collider. However, note how the visual over here, there's no collider, and inside there's no collider, there's only visuals. Again, this is the same thing that relates to separating logic and visuals. Basically, the visual prefab, this one only has visual components, so only meshes, animations, and that sort of thing. And the main parent game object, this is the one that is going to have all of the logic components. So that means any kind of scripts behavior as well as any colliders. So over here on the parent game object, let's add a new component. Let's find a box collider. Again, make sure you add a box collider, not a box collider 2D. And I chose a box collider just because this is the shape that makes most sense for our counter. And now let's scale the box collider. Again, that's the box collider, not the transform, so leave that one with the scale of 1, 1, 1, that's good. And over here on the box collider for the size, let's put it up with a size that fits the visual, so 1.5, 1.5, 1.5. And finally, we just need to lift it up a bit. Over here on the scene view, you can see those little green tiny lines. These refer to the box collider shape. So let's lift it up by a little bit in order to make it perfect. Let's put it up by 0.5 on the Y. Alright, so there you go. That one does have the perfect shape. If we test just like this, it should already be working. So okay, so here's my player, and if I move towards it, and yep, there you go, it does work. So it is a solid object. I cannot go through it. Okay, great. Let's just visually rotate the collider. So let's do that, and again, for rotation, let's make sure we rotate the parent game object and not the visual. We want the visual to be on rotation 0, 0, 0. Okay, great. So on the parent game object, let's just rotate it around. By the way, here's a quick Unity tip. If you want to rotate, hold down Control and then click to rotate. And now instead of rotating on every angle, it goes on a 15 angle increment. So just hold down, and this way you can easily get it to 180 degrees. So that's just for fun, just to make it face the player. Okay, great. So now let's interact with this counter. And doing this is actually super simple. We already learned how to do a raycast to handle collisions, and for interactions, that's exactly the same thing. So let's go into our player script, and we're going to do a raycast to handle that. But before we do, let's organize our code here. Let's make a proper function to handle our movement. So let's make it private, since this is going to be a local function. Return void and call it handle movement. And then inside, let's put all of this code. So let's copy all of this, put it in there, and then on update, we simply call this function. Okay, great. And now let's make another function. So private void, let's call it handle interactions. And we just call this function on our update. Okay, great. Everything is much more organized. So now here, let's do a raycast. So once again, go inside physics, do a raycast. For the origin, let's start on transform.position. For this, obviously, we want the move direction. So one approach would be to make this a field variable stored up here, so that way we can access it in both functions. However, if you remember how we handled the whole issue with the diagonals, basically we're modifying the move direction. So if we're moving diagonally, then this one modifies to only move left or right. We don't want that for the interaction. We want pretty much the exact same one, even if it's pointing towards a solid object. So let's not make this a member variable and reuse it. Instead, let's just grab it again, create it again over here. So we get it, and we want this one even if it's pointing towards a solid object. So let's use this as our move direction. And now for the distance, let's define a fixed distance. So something like 2 units would work. And also here's another very important lesson with regards to writing good, clean code. So you would think to write code like this. So let's put the 2 right in here. That would work, everything would work perfectly. But then let's say you get back to this code after 1 week. Would you remember what this 2f means? The answer is probably not. You would probably very easily forget exactly what this means. So because of that, you should never use numbers directly in the code like this. Instead, you can either make a field up here if you want to make it customizable, or much simpler is actually what we already did previously. So let's define a local variable with a proper name. So let's define a float, and this one is going to represent our interact distance. So let's call it exactly that, interact distance, and let's put 2f. And over here, instead of using a number, let's just use that variable. Now, if we were to get back to this code after a long time, it would be extremely clear what this parameter represents. The technical term for what we did here is called magic numbers, and I've also covered them in detail in another quick video. But as a rule, always remember very simply, never use magic numbers. Okay, so with this we have our raycast. It's pointing forwards for this distance. But this is actually not very useful, because the raycast, this one only returns a boolean. So all this tells us is if there's something in front or not. It does not actually get us the actual object reference. So for that, let's use a different version of the raycast function. So as you can see, we've got all kinds of versions. In order to get the object reference, let's use this version right here. This one which has an out parameter for a raycast hit. Note the out keyword here, this is important. This means that this is an output parameter, whereas the other parameters, those are all essentially inputs that you give to the function, whereas this output, this is basically a value that the function outputs. So let's use this. So we've got the origin, we've got direction, then we've got the raycast hit. In order to use it, we need to make sure to write the out keyword here. And then also very important, we need to write the type. So let's call it raycast hit, and then the name, so let's call it raycast hit. Basically what we're doing here is essentially defining a variable of this type with this name. We're defining it and giving it to the function immediately so we can use it afterwards. If you don't include the type, if you just include the name, then you get an error because this name, raycast hit, this was never defined. Alternatively, you can define it before you pass it in. So over here, you can do a raycast hit, and just like this it works because you are defining it here and using it here. But in order to make the code a bit more compact, you can just define it here in the same place where you get it. Okay, so let's use this. And with this, the function still returns just a boolean, so just hit something or not. But then we've got the raycast hit output. This will be filmed with data from the collision if we do hit something. We can inspect this to see what data it contains, so you can right-click on top of the type, and then go to definition. And up here we do see the definition for the raycast hit struct. You can see this is a structure to get information back from a raycast. You can inspect this to see all of the kinds of things that this one returns. For example, you have a vector3 point for the impact point in world space where the ray actually hit a collider. You can get the normal of the surface and so on, so you can get all kinds of things. For our use case, what we want is to identify the object that we hit, and for that we can use the transform. So this is going to be the transform of the rigid body or the collider that was hit. So let's just do a quick test. If we hit something, let's do a log on that object. So let's do an if. So if this one is true, then that means we hit something. So if so, let's do a debug.log, go inside the raycast hit, and log the transform. Okay, so like this, we should be able to see on the console if we do hit something. Let's also do an else, just to be able to easily see when we hit something. So on else, let's just log an empty dash. And in our game, in order to make sure that our collision is working, that we are correctly detecting it, let's just duplicate this object. But before we do, let's make this a proper prefab. If you have an object of a certain type that you want to create multiple instances of it, you should be using a prefab rather than just duplicating an object. That way with the prefab, if you make any changes to that prefab, it applies to all of the copies of that prefab. So let's first make this one a prefab. And again, since this is our first prefab, let's first make a nice folder to keep things organized. So a folder for our prefabs. And to make a game object prefab is super simple. You just click and drag directly from the hierarchy and drop it inside the folder. There you go. There's our prefab. And now let's just duplicate this. Make sure it has a different name. So it has a 1, so that's enough. With this, we should be able to see it just for testing. Let's put it just off to the side. Okay, so let's see. So here we are, and on the console we see a dash, so by default we are not hitting anything. Okay, so that makes sense. Now if I move towards this object, and if there you go, it does identify that object. And if I stop moving, it stops identifying. Okay, great. Now if I move towards this one, and if there you go, this is the one with the name of 1, and this is the one with the name of none. Alright, awesome. So just like this, we are correctly identifying what object is in front. Except we also have an issue. So if I move towards the object, then yep, it does work. But if I stop moving whilst I'm still facing that object, right now it's returning none. Now the reason for that is because of the move data that we're using here. If we're not moving in any direction, then basically this vector will be 0, 0, 0. So we're going to be firing a raycast towards no direction at all, so obviously it's not going to hit anything. The solution to that is super simple. We just need to keep track of the last interact move direction. So let's go up here, define a field for that. So let's make a private. Let's make a vector3 and call it the last interact direction. And then down here when we have our handle interaction, so we get the movement here. Okay, that's great. So then we just check if the move direction is different from vector3.0. By the way, this is a constant, a shorthand for 0, 0, 0. So if it is not 0, then that means we are moving in some direction. So if so, let's set the last interact direction to this move direction. And basically if it is not, if move here is 0, then we are not going to modify this. So this one is only going to contain the last interact direction. And then down here, instead of using the move direction, let's just use this one. So that way, even when we stop moving, we are still going to be using the last interact direction. Okay, so with this, let's test. So here we are, and if I move towards it, yep, it works. And if I stop moving, and yep, it still works. All right, great. So we can move towards it, point towards a certain object, and then, yep, it still works. Okay, great. Now let's actually interact with this counter. And to do that, let's make a class for the counters themselves. So let's make a new script, a new C# script. Let's call it the same name, so clear counter. Okay, there's our script. Now, very importantly, for attaching the script, remember that we have two instances of our prefab. If you just select it in the hierarchy and you just drag it on there, if you do that, then you're not actually adding this script to the prefab itself, you're only adding it to this specific instance of that prefab. So if you look at this one, yep, it has a script, but this other one, which is a copy of the same prefab, this one does not have it. Also over here on the inspector, you can see the little script icon has a nice little plus. That means it is something that you are adding on top of the prefab. So that means this script is not present on the base prefab. Basically, this is not what we want. We don't want just this object to have this script. We want all instances of this prefab to have this script. So instead, let's get rid of this one from here. We want to modify the prefab itself. So one way to do that is to select the prefab on the project window. So here it is, the actual prefab. And now we can drag the script on there. So that works. Or another alternative is select the prefab in the hierarchy. And on the inspector over here, we see a nice button to open the prefab. And if we actually go into scene view, then we can see what that does. So with the object selected, so this is an instance of that prefab. But if we click on open, then essentially we are opening and we are working inside the prefab. So now if we make sure to add our script, and let's go back outside this prefab. So on the top left corner over here, we can see where we are. So we were inside our scene and then we are inside the clear counter prefab. So if we click on the scenes, we can go back. Now it tells us that we made some changes to the prefab, so let's save them. And yep, we added that script and we can see both instances of the prefab, they both have the same script. And we can see on there on the icon that this is not an override. This is an actual script added on the base prefab. So whenever working with prefabs, always make very sure that you are adding it on the right place. If you want something on the base prefab, make sure you either add it on the prefab itself, or go inside the prefab by double clicking on it, or select an instance in there and open to go inside the prefab. So always keep in mind differences between a prefab and an instance of a prefab. Okay, so we have our script, let's open it. And over here, let's just make one super simple function. So let's make it public because we want to call this from our player class. Let's return void and just call it interact. Okay, that's it, super simple. For now, let's just do a debug.log and just say interact. Okay, so that's it. And now over here on the player, when we have our handle interactions function, so we interact, we do our raycast and we find out if we hit something. So when we do, the first thing that we should do is identify what this transform is. So is this something just like a dumb cube, or is it an actual counter? Now, when it comes to identifying things, this is another place where a lot of beginner tutorials would teach you to use the Unity tag system. So that's over here in the editor when you select any object. Over here in the inspector, you can see a tag, so you can see untagged and you can add all kinds of tags. This is something that a lot of beginner tutorials teach, but Unity tags are horrible. You should never use them. I covered in more detail why that is in the advanced concepts video. The main reason is because of, well, pretty much the same thing that I mentioned a while ago when we were handling animator parameters. So we were doing this and I talked about how this one takes a string and how strings are a horrible way for identifying objects. They are very brittle, very error prone, it's very easy to make mistakes. And tags have the exact same problems because tags are strings. So we do not want to use tags to identify objects. Instead, over here on the player script, let's use a different method for identifying objects. And the best way to do that is to simply get our counter component. So we have our transform, and then from inside that transform, we can call the function try_get_component. This one then takes the type of component. And again, note how this is an out parameter. So let's put out, and we want to test if this is of type clear counter. So clear counter, and call it clear counter. And this one basically does the same thing as a raycast. So it returns a boolean, so either true or false. So if this one is true, then that means that object has that component. So over here we know has clear counter. By the way, if you're not familiar with try_get_component, this is pretty much the same thing as the regular get component, except it automatically handles the null check for you. So if we just do this, it's exactly the same thing as this. So you do an if, raycast hit, let's access the transform, get component. Component of type clear counter. And actually this one is not inside an if, but let's store this. Clear counter equals this. Then you do if this one is not null, then we know has a clear counter. So basically what we have up here is the exact same thing that we have down here. So just using try_get_component, it's just a bit more compact and I find much easier to read than to always get the component and test if it is not null. Over here we just have one function with a nice out parameter and everything works perfectly. So that's the try_get_component. I much prefer that method, so let's use that. By the way, on the try_get_component, over here you can see it has a type inside some angled brackets. Basically these are called C# generics. These are an extremely powerful C# tool. I have a dedicated video on them and I've used them in tons of videos. Definitely go ahead and learn about them. Basically, this lets you write code that works with many classes, not just one specific type. In this case, the try-get component can work with any type of component. So it can be Unity built-in components, or it can be components that you made yourself. Then if it finds a type, it returns true. So for right now, it's not strictly necessary to know the specifics about how C# generics work, but definitely make sure you add that video to your queue and watch it afterwards. C# generics are an extremely useful C# feature. Okay, so we do this, and basically if we are inside of here, then we know this object has a clear counter, and we have our clear counter reference. So over here, it's super simple. Let's just call the interact function. Alright, so that's really it. Let's just get rid of the else. We no longer want that log, so we should be able to see a log whenever we call our interact in a counter. Alright, so here we are, and if I move around, okay, that's good. Over here, the console is empty, alright. Now if I move towards the counter, yep, there you go, I'm interacting with it. And if I move towards this one, yep, there you go, interacting. Alright, great. So with this, we are correctly identifying the object and interacting with it. Now let's just do one final thing. Over here, we are doing a raycast to find the counter. And right now, we are doing a raycast towards any object that has any kind of physics collider. So maybe that's our counter, or maybe it's just a random wall. For example, if we had an invisible wall in front of our counter, then this code would not work. That's because this raycast and this raycast hit, it only returns the very first object that it does hit. So if the counter was behind the wall, then the raycast hit object here would be a reference to that wall object. Perhaps that's what you want, or perhaps not. In that scenario, one thing you can do is instead of using raycast, you can use the function raycastAll. And difference for this one is instead of returning just a boolean, just true or false, instead it returns an array of all of the objects that it hit with that raycast. Then you could cycle through them and identify the object. So that's one approach. Or another option is over here on the raycast. If we look at these function versions, we can see that some of them has what it's called a layer mask. Basically, you can set a certain game object to a specific layer, and then if you use a layer mask, then you can make sure this raycast will only hit objects within that layer. Anything not on that layer will be ignored for that raycast. This is super useful, so let's learn how it works. For a layer mask, we can go up here and define a type of layer mask. So let's make another serialized field, private, let's make it of type layer mask. Let's call it the counters layer mask. Okay, so we have this, and then down here when we have our raycast, let's use it. So let's find the function that matches up these parameters with the layer mask. So here it is, we have the origin, then we have the direction, the raycast hit, the max distance, and then finally we have our layer mask. So let's use our counters layer mask. Okay, great. Now back in the editor, let's select our player game object, and yep, there we see our field of type layer mask. And you can see how we can select all kinds of layers, and how we set these layers to an object is, let's just select our clear counter. Although again, we want to make sure that this change applies to all counters, not just this one specific instance. So let's go inside the prefab. And over here, we've got a field for our layer. And you can see we've got a bunch of default layers. And then we can add some more. So let's add some layers. And over here, let's go to the first empty one. And let's call it counters. Okay, we've added the layer. So let's go back, select our object. And now on the layer, let's put it on the counters. Now it asks you if you want to modify the layer for all child objects. Now, since we made sure to keep the logic and physics components only on the parent object, let's just modify this one and leave the other ones on the default. So let's just modify this object only. Okay, so with that, our counter is now on the counters layer. Let's leave the prefab, make sure to save it. Okay, great. And now if we go back into the player and over here on the counters layer mask, yep, we do see the counters layer. So let's just click the selected. By the way, this drop-down menu, you can actually select multiple. So you can select all kinds of layers, so this is multi-select, but we only want the counter, so only like this. And just like this, if we do test, and now if I move towards it, and if there you go, got the nice interact on both of them. So everything still works exactly the same, but now if we had another physics collider in front of it, it would still work because we're using a layer mask to only raycast against counter objects. Alright, great. Now I should point out another way to work with layers is with something called a bit mask. That's a bit more advanced. Usually the layer mask is much easier to follow. But if you want to learn about bitmasks, go ahead and watch that video. And also another quick note, in this game we're only going to interact with one single object type. It's only going to be a counter, even though we're going to have multiple types of counters. But for games where you want to interact with multiple objects, like for example having an interact action to talk with an NPC, and another one to open a door or push a button, for those kinds of multiple interactions, to build a system like that, make sure you look into my How to Interact with Objects video. It covers how to do all of that, how to interact with all kinds of objects. It's all based on C# interface, which we're actually going to use in a few lectures and also have a dedicated video on that topic. So keep following this course, but then make sure to watch those videos, add them to your watch list, and make sure you do watch them. Watch that how to interact video. It is something that is necessary in so many games, and most tutorials don't actually teach you the correct way of doing it. Anyway, so back in our game, we are correctly identifying and interacting with each counter. But obviously we don't want to interact automatically just like this. Instead, we want to press a nice button to interact, so that means we're going to need to create an interact input action. So let's do all of that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a proper interact input action, and in doing so we're also going to learn about a very powerful C# feature called events. Okay, so here we have our game, so we have the player, and if we move towards the counter, yep, we are correctly identifying it and interacting with it. Except of course we don't want the interaction to happen automatically, it should be on a player input. So let's make our interact action. Let's go inside our player input action, so let's double click on it. And let's make a brand new action. So we've got the move, and now we're going to have another one. So let's click on the plus icon. For this one, let's call it interact. And for this one, action type, we do want it to be a button. Okay, great. Then on the default binding, let's go into path, let's listen. And by default, let's bind it to the E key, just like so many games. So let's go ahead, select this one. And once again, let's make sure to save the asset and let the C# class be generated. Okay. Now over here in our game input script, in order to listen, that is very simple. So we go inside the player input actions, then inside the player action map, and then we can find the interact action. And then over here, we can see a whole bunch of events that we can interact with. We've got these three: cancel, performed, and started. These are the three phases of every input. Again, I cover these stages in detail in the input system video. The important thing is that these are C# events, which I also covered in another dedicated video. Essentially, they are a way for how you can write code to then get notified when something happens, rather than running code on every single update, constantly testing something. For example, over here on the movement is a pretty constant action, so it does make sense to ask the input on every single update if any movement is pressed. But for an action like the interact, the player is only going to press that, say, once every 5 seconds, so it makes no sense to constantly check for that action on every single update. Instead, we just want to be notified when that action is triggered, and that is exactly what an event does. Again, watch the dedicated video to learn all about C# events in detail. They are insanely powerful, and we will be using them more and more as we go through this course. For now, here are the absolute basics. Events have publishers and subscribers. The publisher creates and fires the event when something happens, and the subscriber listens to that event and gets the listening function called when the event is fired. Now on the generated C# class, we've got these three events. The one that we want for this case is the performed event. So let's go into this one, and basically we want to add a listener to that event. And we can subscribe to that by doing plus equals, so this assigns a listener to that event. And now Visual Studio has a nice shortcut, so if we press on tab, yep, there you go, it automatically creates the function. Now if you're not using Visual Studio, you can just manually write this function. The only thing you need to make sure is that the function signature perfectly matches the event signature. As usual, we can inspect the event, so we can right-click on it and go to definition. And yep, here is the definition. And you can see that this is an event of type action with a callback context. Action is what is called a delegate. I also have a video on delegates if you want to learn more about them in detail. For now, we don't really need to worry about what is a delegate, we just need to use it. So in order to subscribe to the event, we need to make sure that this one returns void, because an action returns void, and needs to have a parameter of this type, callback context. If I erase this parameter, yep, there you go, now we have an error because the function signature does not match. So it always needs to match the exact same signature, okay? And also one more note over here, when subscribing to the event, make sure you only add the function name, meaning you do not add parentheses. We do not want to call the function, we just want to pass in the function itself as a reference. Okay, so now when the player presses the interact action, it's going to fire off this event, which in turn will call this function. So over here, let's do a debug.log just to see what this contains. For example, let's print out the callback context. Okay, so let's see. So here we are, and if I press on E, yep, there you go, I've got a nice event. Okay, great, so with this we know when the player presses the key. Now the next step is, how do we get the player class? How do we get this one to know when this is performed? And the answer is we're going to do the exact same thing. We're going to make an event over here on the game input class, and the player will listen to that, which in turn the game input grabs from the input system. Again, the whole point is separating our concerns. So the player does not care about the input system, does not care about the interact action, it only wants to know when something related to interact happens. So over here, let's make that nice event. First of all, let's make it public because we want the player to access it. Then we need to add the event keyword. Next, we add the delegate type. Like I said, you can learn more about delegates in my dedicated video. You can create your own custom delegate for your event, or you can just follow the C# standard and just use the standard event handler. And this one exists inside system. So let's make sure to go up here and add using system. And this one has the event handler class. This one is pretty much the C# standard for events. As you can see, it returns void, it has an object for the sender, and an event args parameter. Like I mentioned in the events video, you are not forced to use this delegate. You can use whatever delegate you want. Like for example, you saw that the performed used an action delegate. So you can use anything you want, it's just that the event handler is the C# standard, so it's easier to follow. Unless you have a specific reason to deviate from the standard, you should probably use this one. So let's use this, and then finally for the name, usually you start the name with on and then whatever happened. So in our case, let's go with on interact action. Okay, so we have defined our event, and now for firing it, let's go down here into when we have the interact performed, and let's go into the event, and for firing it, it's pretty much exactly the same thing as calling a regular function, so we just call it with parentheses. Then usually for the object sender, this is a reference to whoever is sending this event, so usually the this keyword. And then for the event args, this is in case you want to send some arguments with the event. In our case, we don't really need to send any extra data for this one, just firing the event is going to be enough. So for that, we can use the constant event args.empty. Okay, so that's it. With this, we are firing an event. Except just like this, we're actually going to have one potential error. If we have no subscribers, no listeners to this event, then essentially this field will be null, so this one over here is going to trigger a null reference exception. Let's do a quick test just to see this happening. So here, if I press on E, yep, there you go, we have a null reference exception. So when working with events, you need to first test if there are any listeners, and only then do you actually trigger the event. So you do if this one is not null. If it is not null, that means there are some subscribers, so we can fire the event. So like this, it will work, but there's an even more compact way to do this, which is perfect for events. So instead of this, we've got our onInteract action, then we can add a question mark. This is called the null conditional operator. Basically, the code is going to execute from left to right. And then when it gets to this question mark, it's going to evaluate the left side. And if it is null, then the execution will stop right here on the question mark and will not throw any errors. Whereas if this one is not null, then it continues executing to the right. Except with this syntax, we have an error. We cannot put parentheses directly after the question mark, but what we can do is simply just call invoke, and that does the exact same thing, that calls a function. So what we have here is exactly the same thing that we had previously. So what we have over here and over here, these are the exact same thing. It's just this one is much more compact, and especially for events, this one is super useful. Okay, so with this, we are correctly firing for our event. Now let's actually listen to it. So let's go over here into the player class, and let's listen to our event. Let's do it on a private void start, make it on start and not on awake. This is a very important rule, which I'm actually going to cover in detail in the next lecture. But for now, just make sure to listen on start and not on awake. So over here, we access the game input. Then let's access the onInteract action event. And as usual, let's listen to it. So let's use press tab to listen to it. So it is exactly over here that we want to run our interact code. So let's go down into the handle interaction code that we had previously, so this one. So let's copy paste all of this code, put it up here. So we get the interaction, go into the object and trigger the interact. Now obviously code duplication is a big no-no. So we're only duplicating our code just for a quick test, just to make sure it works. Once again, refactoring is super useful, so we're going to refactor this code to get rid of code duplication in the next lecture. But for now, we just want to test to make sure that this does work. So let's just remove the interact over here from the handle interactions. So the only interact function being called is over here when we have our actual input. So let's test and see if we can press to interact with the counter. Alright, so here we are, and as I move around, if I approach the counter, yep, there you go, we no longer have the automated interaction. And now if I'm facing the counter and I press the interact key, yep, there you go, here we have our nice interaction. Alright, awesome, so I can approach, I can interact and do whatever I want. Alright, so here we learned about C# events. These are super powerful, so if this is the first time you're hearing about them, then you've just added an awesome new tool to your toolbox. Definitely make sure you watch my dedicated video to learn about them in more detail. Events are super useful. The next thing we're going to need is just a visual to highlight the current selected counter, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add a visual to our selected counter, and in doing so, we're also going to learn about the very useful singleton pattern. Okay, so over here we already have the logic to identify the counter in front of the player, and we can interact with it. However, whilst the logic works, there is no visual indicator at all, so let's add that. Now, as usual, the super quick and dirty way of doing it would be pretty simple. Over here on the player script, we could just directly enable a visual mesh on the target counter. So down here on the handle interaction, when we have this, over here we could tell the clear counter to enable some kind of visual. Technically that would work, but that would be some pretty dirty code. We would basically be making the player responsible for enabling some kind of visual, which would mean that we were mixing logic with visuals. Again, we always want to try separating the logic from the visuals as much as possible to keep our code nice and organized. So instead of doing the quick and dirty route, let's do it properly. Back in the editor, let's create a brand new C# script. Call this the selected counter visual. And now let's go into the prefab. Again, let's go inside it. So let's select the clear counter on the hierarchy. Then on the inspector, let's open up, go inside the prefab. And now let's select the visual inside it and let's duplicate this. So you can press Ctrl D to duplicate it. Let's name this one selected. And then inside there's a visual with a mesh filter and a mesh render. So over here, let's swap out the material. So let's click on the circle icon. And now included in the assets is this material, counter selected. So it's all the way, up here, the counter selected. Basically, it's just a solid white color with a low alpha. So on the kitchen counter inside the select game object, let's make sure to use this one. With this, we have kind of like a ghost visual. So if we enable and disable this game object, we can see the difference. Also, let's do one tiny thing, which is right now we duplicated the actual visual, meaning that these objects are exactly the same. They have the exact same size. And when that happens, you might end up with some rendering bugs. If two meshes are on the exact same position, you might sometimes see the colors constantly flip back and forth. So in order to make sure that doesn't happen, let's make this one, the selected, a tiny bit bigger. So over here with the selected game object selected, on the inspector over here we've got the scale, and also we've got this nice little button here. If it's like this, then we can modify each proportion differently from one another. Whereas if we click, now these are all linked. So now modifying one will modify all of them, so let's put this on 1.01. Meaning this one is going to be literally just 1% bigger. So that's enough of a difference to make sure we don't have any rendering bugs. And by default, let's also start with the visual hidden. So let's do that not on the parent select game object, but rather on the kitchen counter inside of it. Let's make sure to disable this game object. By the way, the quick shortcut is Shift, Alt, and A. You can enable or disable the object, very useful. So let's start with this one disabled so that it's hidden. And basically the goal is that when this counter is selected, we're going to enable it and show this visual, and when it's not selected, we're going to disable it. Okay, so over here on the selected, let's add the script that we made, so the selected counter visual. All right, so let's open it. Now here, first thing we need to know is which counter is selected. Meaning we need to know which counter the player is currently looking at. So let's go over here onto the player script, and let's basically just do some simple logic to keep track of the selected counter. So over here, let's make a field, so a private. Let's make it of type clear counter and just call it the selected counter. Then down here we have our handle interactions logic. Okay, so we do all of this. We try to find a counter in front, and if we do find it, then we have it here. So here, let's just check if it's different. So if this clear counter, if the one in front is different from the current selected, then let's set the selected to this one. And let's also make sure to essentially unselect. So we want to make sure to set this one to null when there's nothing in front of the player. So if the raycast does not hit anything, then there's nothing in front of the player. So let's set the selected counter back into null. And also if there is something, but that something does not have the clear counter script, then it's also not a counter. So over here, let's also do an else selected counter equals null. So basically if there's a counter in front of the player, then it's going to set it. If not, then it's going to be null. Let's just do a simple debug.log to check on the selected counter. Okay. And also, just briefly, now that we've made this selected counter logic, actually up here when we have our interact action, like we saw, we were previously copying some duplicated code, but now we no longer need this since we already know the selected counter. So over here when we've got the interact action, let's just check if we do have a selected counter. So if it is not null, if so, then we go there and we call the interact function. So that's it, we no longer need all of this logic. Okay, that's great, so let's test. Back in the editor, let's go back into scenes. Let's make sure to save the prefab. Make sure the script was attached, save it, and let's hit on play. And right now, if I'm down here, yep, there you go, we've got null. And as I approach, yep, there you go, that one is a clear counter. And if I move towards this one, yep, it's that one. Okay, so basically we are keeping track of the currently selected counter. Now basically we just need to notify the visual whenever this one changes. So when this one is pointing at that one, or pointing at null, or pointing at that one, we need to know when that happens. And for that we basically have two options. Now one option is pretty much what I mentioned a while ago, which is over here we have the selected counter, so we can run some kind of logic on the selected counter. We can do that over here on the player. Then perhaps over here the counter would fire off some kind of event saying it has been selected, and then the counter visual would listen to that event and update itself. Now that approach would be useful if we wanted to add some kind of logic on the clear counter while selected, and that approach would also have the benefit where the visual counter would only listen to events on its own counter. So that's one approach, pretty much a very direct approach. But another one is very simple. The player would simply fire off an event whenever the selected counter changes, and then all of the counter visuals would listen to that event. Then they would identify if the event relates to that counter, and if so, update their state. Now the benefit of this approach is that the logic doesn't get bothered with any selection logic. So over here the clear counter script never really knows if it's selected or not, and that's a good thing because it doesn't need to know. Although the potential con with that approach is that all of these selected counter visuals are all going to listen to the same event. So both approaches have pros and cons. Here let's go with the second approach where all the counters listen to a player event. The potential performance con doesn't really matter on a game of this scale. We're only going to have about a dozen counters, so even if 11 of them are just wasting on listening to the event, it's really not going to matter. And going with this approach will actually help us learn about the singleton pattern, which is extremely useful. So first let's go over here onto the player class and let's make the event that we're going to fire. So as usual, let's make it public so we can access it. Let's make it an event. And as usual, let's also use the standard event handler. Let's make sure to add using system. So here Visual Studio adds it automatically. Okay. And let's call this on selected counter changed. Also, this is a great moment to learn about the event args. This is how you can extend a C# event in order to pass in some more data. So how you do it by following the C# standard is very simple. We just create a class. So over here, let's make a public class. Then for the name, usually you include the name of the event with event args at the end. So in this case, on selected counter changed, and then event args. Then on this class, we make it extend event args. And finally, inside the class, we add whatever data we want. Like for example, we want the current selected counter. So let's make a public clear counter and put the selected counter. Okay, so we have this nice event args with a bunch of extra data, and then over here on the event handler, we use the version that takes a generic and we pass in our event args. Again, I covered the generics in more detail in a separate video. Definitely go watch that one if you haven't seen it yet. C# generics are one of C#'s most powerful features. Okay, great, so we now have our nice event. Now let's fire it off. So let's go down here to when we're modifying the selected counter. So here it is, we've got all of these ones. So when we modify, let's fire off the event. So we go into this event, and as usual, let's use the question mark and then call invoke. Then for the object sender, it's going to be this, so pretty much the standard. And then for our custom event args, let's construct an object of that type. So construct a new object. And then inside we pass in the selected counter and we set it to this selected counter. Now don't be confused by the fact that we're using the exact same name. If you actually mouse over the cursor, Visual Studio actually helps you by telling you which object refers to this. So with the cursor here, note how all of these are highlighted, but this one is not highlighted. That's because this is the field inside the onSelected counter changed event args, whereas this one out here is the object that we're referencing in here. So even though these two have the exact same name, here we're accessing the field inside of that, and we're assigning it to the reference that we have down here. Okay, so that's really it. We're firing off the event when the selected changes, and we're passing it in. And let's also make sure to do it over here, so let's copy and paste some code, and there you go, just like this. Except, of course, we can already see a bunch of code duplication. Usually that means it's time to refactor, so let's do that pretty quickly. Let's go down and make a brand new function. So let's make a private void. Let's call it